One you see on my monitor is called flow graph. In this flow graph, this circle summer, this circle summer, this circle CUDA, these circles represent function node. This arrow, this arrow, this arrow, this arrow, these arrows represent data flow or message flow. What flow graph makes a big difference from other parallel constructs is that in the flow graph, these function node, these function nodes run asynchronously or concurrently, which result in maximum scalability and performance in our application. Once you learn Intel TBB Flow Graph, we can also learn CUDA Graph. CUDA Toolkit version 10.2 introduced CUDA Graph. We will learn this CUDA Graph too. If you follow my current and future sessions, you will eventually learn Intel TBB Flow Graph. Hi everyone, my name is Thomas Kim. Today is June 23rd, 2022. This is my 10th episode about C++ 17, 20, 23 and other programming technologies. In this episode, we will compare broadcast node, input node. Using broadcast node and input node, we will implement this identity A plus B and A minus B. These two computations will be executed in parallel or concurrently. Then the result of addition and the result of subtraction, these two computations will be joined. Then we compute the final result using Intel TBB Flow Graph. If you want to follow my current and future sessions, I would highly recommend you to watch my videos as listed in this playlist in sequential order. If you don't watch them in sequential order, it might be very difficult for you to follow my current and future sessions. Without further ado, let's get started. Start Visual Studio Code. Open your working folder CPP 17 2027 parallel. Select empty space in this window. Click this button 0, 10, Flow Graph. Click this button graph.cpp. Hit enter. Ctrl B. I will copy and paste some links. Include talk play fun, output HPP, include talk play fun, chrono random. Please remember namespace, alias, flow, TBB, flow, namespace, TPT, talk play fun, types, namespace, TCR, talk play fun, chrono, random, talk play fun, stream, print, auto, and talk play fun, and I would copy, paste, and L, and L. Also, auto, NL, talk play fun, NL, copy, paste, and L, NL. Void test, broadcast, node. Int main, copy the function name broadcast node, paste it here. We define context per or n10 flow graph g or fn add. Please understand that we take tuple int constant L value reference tuple. Don't forget semicolon. We add 2 elements of tuple. This tuple has 2 elements. We can do addition like this. std get 0 tuple plus std get 1 tuple, then return. We can do this, but to help you learn modern C++ or L value reference A, B, we can use structured binding, then return A plus B. So these two statements are identical with this one. I would copy, paste it here. This is subtraction. Sub. I will clean our code like this. Copy once again. Paste. This is multiplication. This is subtraction, so it should be minus. This is multiplication plus. Now we define broadcast node. This broadcast node takes std tuple int, then nd broadcast. It requires graph. We defined broadcast node. Scroll up. If you control click in this diagram, our broadcast node plays the role of input. Our broadcast node broadcasts a tuple for A and B to scalar and CUDA. Let's keep going. We create a function node, flow function node. We need to take tuple int. This is input type. Then we return int nd add. The first argument is graph, this G. The second argument is concurrency. We will use flow serial. Then we will provide the body. We are defining addition node, so we provide addition. Please understand that we return the result of addition to int. So it should be int. Also int. Also int. Here fn add. We create subtraction and the sub. We create multiplication and the mul. Up to this point, we defined input. In our case, we defined broadcast node for input node, then scalar, CUDA, summer. I would say nd add, nd sub, nd mul. Now we define join node. Flow join node. Join node takes output tuple std tuple int. Then we have to provide buffer type. Flow, we are using queuing buffer. And the join, we provide here graph. So 1, 2, 3, 4, 5. 5 nodes are defined. Here 1, 2, 3, 4, 5 nodes are defined. Now we define data flow. Data flows using edge. Flow make edge from broadcast node to nd addition. Flow make edge from nd broadcast to nd sub. Up to this point, we defined from broadcast to addition, from broadcast to subtraction. We now join from addition and from subtraction. We join the result like this. Flow make edge nd addition nd join, but this is not good enough. Join, this join takes two parameter int as tuple, but nd add, this nd add returns int. So std get 0 from join input ports. So join has a member input ports. From this joins input ports, we select zeros port, zeros input port. In this diagram, we select zeros input port. Again, copy, paste from subtraction we select port 1. Input ports of ND join, we select port 1 for subtraction. Up to this point, we created this arrow represented by edge, and this arrow data flow represented by edge. So we defined this arrow. Now from join to summer, flow, make edge, ND, join, ND, mul, because ND join returns tuple. This is input port as well as output, and mul takes tuple as input, returns int. We define another function, auto fn output. It takes int value semicolon. It simply print out value, and there. We define another function node, flow function node. It takes int, but it does not return because fn ND output. The first comes graph, flow serial, then this fn output. Please understand that in this function node ND output, it takes int, but it does not return. It is void. So we do not have return type here. Or we can just say like this, but it does not work. Instead, we just make it empty. Then everybody is happy. Now, for int I 0 I less than n plus I, we pump message to ND broadcast. Here we can use try put. We have to provide something here. Now auto generator TCR, it generates random number. Random generate type int from -5 to 5. Auto random tuple. We capture generator, then returns. It can be std tuple int. This is return type. Then generator, this is function generator to random numbers. So we call random tuple repeatedly. So random tuple generates random tuple each time it is called. Now we have to wait for all. Now let's try it. I will start with the clang compiler. dir cd 0110 flow graph. clang std C++17 graph.cpp ltbb 12. Don't forget this switch. or c.exe. Hit enter. cls c. Nothing. This means somewhere in our program we haven't connected from mul to output. We haven't made edge. Copy this, paste it here. From mul to nd output, we have to make edge. Also, I will modify this part. auto std tuple. I will fix like this. tuple. Then return tuple. Before return tuple, print tuple. And there. Also, I will make it bigger, 20. We build again. cls c. So this is our result. Let's make it 100. We build again. cls c. This is stick together. This message with a square bracket, these are tuples coming from here. And these numbers are coming from here. The values are sticked together. If we want to prevent such misfortune, the values, tuple, and the computation results are sticked together. We are using print. This print is global object defined here. If we are using global object, we have to synchronize. Synchronization is something bad. Instead, I will create talk play fun stream prints 2. We are using local prints. Scroll down. Here, print prints 0. It should be L value captured. We don't need flush out to console. Instead, we use NL. NL is just new line character. Also, here L value reference print prints 0. It should be NL. Scroll down. I will make it 1. Now here prints 0 and there. Flush out to console. Prints 1 and there. We flush out to console here. This print defined here This is string buffer. So we flush out like this to console. Now CLS rebuild CLSC. This is the computation result. This is the input. In this code, we never used synchronization, but still it works perfectly. We used broadcast node and defined here. Now we will use input node. Copy, paste, scroll up, test input node. Copy this function name, control and paste it here. Disable it. Now scroll up. We will copy, cut, scroll up, here we will paste. We don't need this. We don't need broadcast node. Now this function takes TBB Flow Control L value reference FC. Please understand that this namespace is not flow. This namespace is TBB, then follows flow control. I would give line break like this. Here, if we will capture n state into 0, then it should be mutable. State less than n, we make block, else FC, this FC is from here. Stop. Return tuple. This is tuple because we defined return type as tuple. I would indent like this. Then we need to increment state. With this, flow input node std tuple int and the input we provide g and random tuple, the generator. Copy this. We do not have any broadcast. Overwrite it here. Overwrite it here. Now everything is ready. Don't forget ND input activate. Before we call graph wait for all, we have to activate ND input. Now we build again. CLSC. The result is exactly the same. For your reference, I would copy this command string, Control Home, paste it here. With Microsoft Compiler, dir cl ehsc, don't forget ehsc, std c++17 graph.cpp fe m.exe, hit enter. clsm, it works exactly the same. Copy this command string, paste it here. For nvcc std c++17 graph.cpp ltbb 12 on.exe, hit enter. clsn, CUDA compiler also works. In fact, CUDA compiler internally uses Microsoft Compiler on Windows platform. Paste it here. For those who are using data parallel C++ compiler, dpcpp qscd c++17, don't forget ehsc no SYCL. This option is optional. graph.cpp or d.exe. clsd, it works perfectly. Copy this, paste it here. Of course, GNU compiler also works like this. If you don't skip my videos and keep watching, you will eventually understand what is flow graph.